Hi everyone! Today is the second part of our discussion on soil formation and development, and we will focus our discussion on the five soil forming factors. Soils are natural expressions of the environment in which they were formed, and the conditions that are present during soil formation affects how much and what kind of nutrients the soil can naturally supply and hold. Soil development is influenced by the topography on which soils occur, the plant and animal life which they support, and the amount of time which they have been exposed to these conditions. Soil fertility, as one of the most important factors in crop production, is greatly influenced by the factors of soil formation. In our previous lecture, I already introduced you the five soil forming factors or CLORP. And CLORP is C for climate, LO for living organisms, R for relief or topography, P for parent material, and T for time. Man is also considered as the sixth factor of soil formation. The combined influence of these soil forming factors determines what would be the soil properties and their degree of expression. Let us now look first on the parent material as a soil forming factor. Parent material can be defined as the unconsolidated and more or less chemically weathered mineral or organic matter from which the soilum of soils is developed by pedogenic processes. When you say soilum, consists of the surface and subsurface layers of the soil, while pedogenic processes means all processes that are occurring in the soil. Parent material is the initial state of the soil system. The nature or type of the parent material influences the soil characteristics and the minerals that will predominate the soil. For example, your parent material is basalt or basalt rock. Basalt consists of small crystals. Hence, you can expect that the soil will be finely textured. When it comes to talking about the parent material, one must be familiar with the primary and secondary minerals. Primary minerals are minerals that have not been altered chemically since deposition and crystallization from molten lava, while secondary minerals are minerals resulting from the decomposition of a primary mineral or from the precipitation of the products of decomposition of a primary mineral. Here are some other examples of parent material and the expected characteristics of the soil that will be developed from it. For example, you have a calcareous parent material. An example of calcareous parent material is limestone. So from calcareous parent material or limestone, the soil could be developed with high calcium content or it could have an alkaline pH. If the primary minerals are the parent material, the primary minerals are known to be resistant to weathering. Example of this is the potassium feldspar. You can expect that your soil or the soil will be coarse textured and it will have high potassium content because of the K or potassium feldspar. If the parent material is or are the secondary minerals, for example, the clay minerals, you can expect that the soil will be finely textured. There are three types of parent material that are called residual or sedentary, transported, and cumulose. Those that are residual or sedentary parent material are those which experience long and intense weathering. For a parent material to be considered or classified to be residual or sedentary, the landscape should have been stable for a sufficient period of time for weathering to occur. The soil that was developed in place or in situ from the underlying consolidated rock. And the consolidated rocks are consists of the igneous, sedimentary, or metamorphic rocks. As what I've discussed in the previous video, igneous rocks are those cold molten lava that originated from within the earth. Igneous rock is the most abundant class of rock in the Earth's crust. It can either be extrusive or intrusive. Intrusive are those having large crystals, and extrusive are those having small crystals due to the differences of the rate of cooling. Example of intrusive igneous rock is the granite that is commonly used as a building material. Example of extrusive igneous rock is the basalt. So this is the basalt rock outcrops, an extrusive igneous rock. This one is the granite, an intrusive igneous rock. On the other hand, sedimentary rocks are the most abundant group of rocks on the Earth's surface. They are formed by the accumulation and subsequent consolidation of sediments into various types of rocks. The key here is sediments, and these sediments are unconsolidated material and have different origins. The origin of these sediments is the weathering, erosion, and or the chemical breakdown of other rocks. And these other rocks could be igneous, metamorphic, or even other sedimentary rocks. The common examples of sedimentary rocks are sandstone, shale, and limestone. And these are your sandstone, shale, and limestone. Moving on, metamorphic rocks are rocks that were greatly altered from their previous condition through the combined action of heat and pressure, usually while buried deep below Earth's surface. The exposure to these extreme conditions has altered the mineralogy, texture, and chemical composition of the rocks. This is a table showing examples of the origin of residual materials and the resulting soil texture. For example, if the origins are basalt, andesite, or volcanic tuff, the resulting soil texture will be clayey. Another, if the origins are granite or coarse sandstones, the soil texture will be loamy or sandy. Another example is if the origins are siltstones or fine-grained sandstones, the soil will be silt loam or silty clay loam in texture. We are now finished discussing the residual or sedentary parent materials. Now we move on with the transported parent materials. And these are loose sediments or superficial materials that have been transported and deposited by gravity, water, ice, or wind. Examples of this are the weathering products of rocks that are not cemented or consolidated. And these materials are classified on the basis of the agents responsible for their movement and deposition. For the first classification, we have the water-transported alluvium, or also termed as alluvial parent materials. Fast-moving water deposits large stones and gravel, while moving water or slow-moving water deposits sands and silts. Parent materials deposited by moving water in rivers or close to river banks are called alluvium. So take note of that. When you say that the parent materials are being moved by water in the rivers or close to the river banks, they are termed as alluvium or alluvial parent materials. And alluvial deposits that occur where a stream frequently floods over them are called floodplains. These are examples of alluvial deposits on the central plains of Luzon and Cagayan Valley. Another parent material that is transported by water is called lacustrine, and these parent materials are carried by water and deposited in lakes. So we have alluvium that is connected with the rivers, and now we have lacustrine that is connected with the lakes. So the coarser sediments, such as the sand and gravel, are deposited in the shallow areas of the lakes, while the silt and the clay, or the finer grained sediments, are deposited on the deeper water areas of the lakes. This is an example of lacustrine parent materials on the tile lake. There are also those that are called marine parent materials, and these materials are carried by water and accumulating in oceans. The waves pounding against coastal rocks also contribute rock particles and sediments being carried towards the sea. Now we move to those parent materials that are transported by wind. There are also three groups. These are the aeolian, loess, and volcanic ash. Aeolian deposits are composed primarily of sand-sized particles, and the materials are the main component of sand dunes, and are carried for relatively short distances. Another is the loess, which consists of silt-sized particles, and this one is being carried in longer distances. Take note, if you say aeolian, consists of sand-sized particles, while loess consists of silt size. Because sand-sized particles are relatively large, they are being carried for short distances. And since silt-sized particles are smaller, they are being carried in longer distances. The last one is the volcanic ash, or the ash from volcanoes. This one could be carried the longest distance. They are also called colluvial deposits or colluvium. These are materials that move downslope by force of gravity and or erosion and collect at the base of the mountains or foothills with little or no sorting. And soils that have this kind of parent materials tend to be coarse and stony. These are examples of colluvial deposits or colluvium. There are also parent materials that were transported directly by glacial ice or moving ice sheet. And since it is not transported with liquid water, the material is not sorted by size. These are examples of parent materials that have been transported by ice sheet, such as unsorted mixture of boulders, gravel, and sand. We are now finished discussing the transported parent materials. Now we have the cumulose or the organic deposits. Organic deposits that have developed in place from plant residues or animal origin and have been preserved by high water table or some other factor retarding decomposition. These deposits are widespread and not restricted to any climatic zone. Examples of this are the peat and the muck. The difference between the peat and the muck is that the peat is composed of undecomposed or slightly decomposed organic matter, while the muck is composed of highly decomposed or completely decomposed organic material. Now we move to the climate as a soil forming factor. Climate is generally considered as the most important factor influencing the physical and chemical weathering processes, and climate interacts with all other soil formation factors. And the primary forces of climate are the precipitation or rainfall and temperature. Rainfall intensity and distribution greatly influences the extent of soil weathering. How? For example, rainfall causes leaching. In leaching, the rain dissolves some minerals, such as carbonates, and transports them into the deeper layers of the soil. It can also be acid. Soils that are in a predominantly moist environment tend to be highly weathered, and in general, areas with more rainfall will have greater weathering and greater leaching. Another aspect of climate is the temperature. As the mean annual soil temperature increases, the weathering of rocks and minerals in the soil will be faster. Well, in fact, for every 10 degrees Celsius rise in temperature, the rate of biochemical reactions in the soil doubles. Warm, moist climates encourage rapid plant growth and thus high organic matter production. Organic matter decomposition is also accelerated in warm, moist climates. The opposite is true for cold, dry climates. Therefore, in the warm, wet climates of the tropics, for example, here in the Philippines, it is typical to have well-developed, highly weathered soils. Now we move to the living organisms. This includes both plants and animals. Plants help in soil formation by fixing atmospheric carbon and adding it to the soil. Organic matter is also added to the soil surface by plant tops and to the subsurface by the roots. Grass roots near the soil surface are fibrous and easily decompose, thus adding more organic matter. That is in the grassland ecosystem, while taproots open pathways through dense layers that allow greater water movement, which in turn aids in the leaching process. It is often common in the forest ecosystem. Root exudates and the sloughing of cells as roots push through the soil are sources of nutrients and energy for the soil microorganisms. Another contribution of plants to soil formation is the nutrient cycling. As the leaves drop to the ground and decay, it adds to the organic matter. Ions and anions are added to water, and when it is intercepted by the above ground vegetation, it can fall and added to the soil via ground drift. So that's all for the plants. Now we move to the animals, how they can contribute in soil formation. Soil animals create pores and structures as they work their way through the soil. The leaves, twigs, and bark from plants fall into the soil and are broken down by fungi, bacteria, insects, earthworms, and burrowing animals. Organisms not only decompose organic materials, they also mix them with the upper part of the soil, and this process is known as bioderivation. Microorganisms and the humus produce act as a kind of glue to hold particles together in aggregates, therefore improving the soil structure. That's all for the living organisms. Now we move to the relief or topography as a factor of soil formation. Topography refers to the shape or contour of the land surface. It may also describe the orientation of the land with respect to the direction of the sun, or it may describe the pressions and elevations of the land. As a soil forming factor, topography is related to the soil's position in the landscape. Some soils occur on the summit of a hill, some on the shoulder, some on the back slope, and some on the foot slope. It is also related to the depth of water table in relation to slope position. As the water table goes up closer to the soil surface, drainage becomes poor to very poorly drained. It is also related to the slope angle and slope length. It determines the amount of water that runs off or enters the soil, or what we call effective precipitation. As the slope becomes steeper, erosion increases, therefore, soil development decreases. It is also related to the slope aspect or the direction a slope faces. In north-facing slope, where temperature is limiting to development, soils are shallower, while where moisture is limiting with less evaporation, soils are deeper. Now we move to time as a soil forming factor. The age of the soil can be reckoned when the parent material is first deposited and land surface becomes stable. The starting point of soil genesis is when plants first grow on the fresh parent material. Soil formation rates are too slow, while in fact it takes thousands or billions of years to be able to build at least 1 centimeter of soil. They are too slow to measure directly, and so ages must be determined or estimated indirectly with some assumptions, such as the soil formation occurs at a constant rate, and soil thickness is the major indication of age, therefore the thicker the soil is, the older it is, and the major processes of soil formation act uniformly over time. The last soil forming factor we have is the people. We can directly or indirectly create soils. When natural soils are not suitable, we can create or extensively modify soils to suit our needs. But of course, the process and the products are very different from natural soils. Examples of this is in terms of large scale, we have the golf courses. For small scale, we have the potting soils for indoor and outdoor plants. That's all for the second part. Thank you very much for watching. Please don't forget to like and subscribe for the continuation of part 3.